Welcome to Computer Science Unplugged. These are a series of activities designed to introduce children to some of the great ideas in computer science without using a computer. You've probably heard that computers store data using the binary number system. They only use zeros and ones. This activity shows how you can store large numbers even if you can only count up to 1. Of course, the trick is to use more than one of these binary digits, or bits. Computers usually store bits in groups of 8, called a byte, but we're going to start our demonstration with 5 bits. Each of these children represent 1 bit. You can either see their card or not. That's a 0 or 1. Each card has a number of dots on it. The one on the right has 1, the next one has 2, then 4, 8 and 16. We just need to count the number of dots they're showing to read off the number they represent. For example, if the person holding the 8 dots is a 1, you add 8 to your total. If they're a 0, then their card doesn't count towards the total. For example, here the bits are 10110, which shows 22 dots, 16, 4 and 2. So 10110 represents the decimal number 22. And here 11000 represents 24, 16 and 8. To convert a number into binary, we take a greedy approach from left to right. For example, to convert the number 25, we start with the 16 on the left. Because it's less than 25, we flip it up. Now we have 9 dots left to show. The next card is the 8, which is not too big, leaving just 1 dot to show. We therefore skip the 4 and 2 card and show the 1, giving our total of 25 dots. As another example, to convert 11 to binary, we can't take the 16, but we do take the 8, not the 4, and then 2 and 1. So, what's the smallest number we can represent? Often the initial reaction will be 1, but of course, it is 0. Now, what's the maximum number? You can work it out by adding up all the dots, but a quick trick with binary numbers is to work out what the next card to the left would be, 32, and the total will be 1 less than that number. So let's look at the patterns that occur if we count up from 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Notice that when we have a lot of 1s in a row, the next number results in all of them changing to 0 and the next card coming up. Here's 16. This pattern continues until all the cards are visible, and then we get a number overflow. We need more bits to count further. If we add one more person, we can now count up to 63. For each bit that we add, we double the range of numbers. 127, 255, 511, 1023. That's right, with 10 bits you can count up to 1023. Notice at 511 every card gets flipped over. This is like going around the clock on your car's odometer. That's why computer scientists think that 1024 is a nice round number. In fact, on a computer, 1K is 1024, not 1000. Of course, you don't need to have people holding the cards. You can make your own set like this and experiment with counting. Or you can count in binary on your hand. Each finger is either up or down. So you can count from 0 to 31 on one hand. And with 2 hands, you can count to 1023. Binary numbers have lots of interesting mathematical patterns in them. There are plenty more ideas for things to do with binary numbers on our website and in the Unplugged books.